Finding longitude out at sea to map your location in the 18th century was a complete nightmare, and the solution to one of the greatest problems of the time was simple: a clock which could accurately tell time out at sea. Sundials first began in ancient Egypt. Then pendulums were introduced. Harrison's chronometer was the ingenious device which solved the problem of longitude, and more recently, quartz clocks were discovered. And finally, atomic clocks, which lose roughly 1 second every 100 million years. We all know that there are 60 minutes in an hour and 60 seconds in a minute, but how long exactly is 1 second? It is 9,192,631,770 cycles of the standard cesium-133 transition. Now that's a mouthful. The electron absorbs a specific quanta of energy, so it gets excited, and it jumps from the ground state up to a wider orbit, the excited state. It jumps up due to resonance, which is when we apply a stimulus to an object, which has a frequency that's almost equal to the resonant frequency of the object, causing it to oscillate to a greater amplitude. The force we apply to the rim of the cup has a similar frequency to the resonant frequency of the glass, so it resonates, vibrating to a greater amplitude, so the sound is louder and can be heard. The same can also be seen with a Chinese singing bowl. The resonance makes the water jump up, and same with this metal rod. In our case, the frequency of the microwaves is similar to the natural frequency of the cesium atom, so the electron becomes excited. The atom then becomes unstable, and the electron goes back down to its ground state. It releases a specific quanta of energy, which we can use to mark one oscillation. Period equals 1 over frequency. This shows us how long it takes for one oscillation to happen, the period, and we can use this for timekeeping. Cesium atoms can be used in a feedback loop to keep a quartz oscillator constant. First, the cesium is heated up in an oven, turning it into a gas. They are then in two states, high energy and low energy, and they are then sent to be separated by a magnet. The low energy atoms are sent to a chamber where radiation is passed through, turning the atoms in a low energy state to a high energy state. High energy ones are sent to a detector. The frequency of the microwaves is tuned to ensure that the maximum number of atoms are excited, and it controls the quartz oscillating accurately. Then an electric counter counts 32,760 oscillations and marks it as 1 second. The accuracy of atomic clocks are essential. For example, they are used in GPS. Atomic clocks are used to calculate missile interception paths too. The Philae probe landed on a moving comet 437 miles away from Earth due to the incredible accuracy of atomic clocks.